Tata. Yeah, good evening, children. So once again, we have to discuss about the number system. Natural numbers. Natural numbers are nothing but counting numbers. So natural numbers are represented with the letter N. We know that counting numbers 1, 2, 3, 4 and so on. So smallest natural number is 1 and the largest natural number is undefined. Next, natural numbers including 0. Natural numbers including 0 are called whole numbers. So what is the smallest whole number? 0. Smallest whole number is 0 and the largest whole number is not defined. Okay. Next, third set of numbers are nothing but integers. Okay, na? So integers are represented with the letter Z, Z or I. So integers are nothing but all positive numbers, all negative numbers, including 0, are called integers. Here you should identify that 0 we are not considering as a positive number or negative number. So 0 is neither positive nor negative. Okay, na? All positive numbers are nothing but natural numbers only. 1, 2, 3 and so on. All negative numbers, -1, -2, -3 and so on, including 0, because 0 is neither positive nor negative. Neither positive nor negative. These set of numbers are called integers. The G is nothing but Jahlan. In international system, they are used to letter Z for integers, so which means to count. Jahlan is a German word. Okay, na? So all positive, all negative, including 0, all called integers. Next, before going to the next set of numbers, so here I need to mention 3 properties. Actually, for every number system, we use some properties like closure, commutative, associative, distributive. 4 main properties: closure property, commutative property, associative and distributive. We'll discuss these 4 topics, these 4 properties later. Before that, you should know about what is identity property and what is inverse property. So let us recall the identity property and inverse property. Let us say one example for you. If you take your ID card, so in that ID card your picture will be printed, right? That photograph represents your identity. Same like in the number system also we have an identity property. Suppose if I take a number 2, for this number I am adding with some number, but the result is same 2. That means the identity of 2 is not disturbed. Identity of 2 is not disturbed. If you add one number, what is that number? 0. What is that number? 0. So 2 plus 0 is 2. So here the number 0 is help to maintain its identity as it is. Okay. So 0 is called additive identity. 0 is called additive identity. Okay, na? Because why additive identity? We are doing addition here. Same way, same number 2, I am multiplying with other number, but the 2 identity should be same. So what is the number will help here? 1. So 2 ones are 2. The identity of 2 is same. Under multiplication, we have 1 is helping here. So 1 is called multiplicative identity. One is called multiplicative identity. Okay, na? Yeah, multiplicative identity. So actually the identity property is, if A is any integer, if A is any integer, A plus 0 equals to 0 plus A equals to A. This is actual definition of identity property. For any integer A, that integer is added to 0, the answer is same integer. Okay? A plus 0 equal to 0 plus A is equal to A. Where A is any integer, here 0 is called additive identity. Here additive identity never changes for any number, whether it is an integer, natural number, whole number, or rational number or real numbers. For in every number system, the additive identity is always 0. In such a way, multiplicative identity is always 1. So A into 1 equals to 1 into A equals to A. Under multiplication here 1 is called multiplicative identity. Clear, children? So number system, we have natural numbers, whole numbers, integers. Integers are nothing but all positive numbers, negative numbers, including 0. That means 0 is neither positive nor negative. And we discussed about the additive identity, multiplicative identity. Additive identity is 0, multiplicative identity is 1. Okay, now. So before that, you should know about non-negative numbers or non-negative integers, non-positive integers. Non-negative numbers. Non-negative numbers means which are not belongs to negative, set of negative numbers. That means 1, 2, 3, 4 and so on. But 0 also a non-negative number, no? 0 also a non-negative number. So we have to include 0 also. So non-negative. The set of numbers are not belongs to negatives. That means 0 is not a negative because 0 is neither negative nor positive. We can take in a non-negative set. 0, 1, 2, 3, 4. Simply we can say that non-negative integers are nothing but whole numbers. Non-negative integers are nothing but whole numbers. Same way, non-positive integers. Non-positive integers means minus 1, minus 2, minus 3 and so on with 0. Okay, na? 0 is in the set of both non-negative integers and non-positive integers even. Clear, children, till then? Right. Now inverse property. So additive inverse, multiplicative inverse, but in your book is given only up to additive inverse. So let us think about an additive number. So additive inverse. So here clearly you should understand that for every positive number there exists a negative number. For every positive number there exists a negative number. For example 3, its negative number is minus 3. Okay. For 5, minus 5. For 2 by 3, its negative number is minus 2 by 3. So if you take any number system, like in integers we have, for every positive integer there exists a negative integer. For every positive integer there exists a negative integer. That means for A is a positive integer, if you consider, its negative integer will be minus A. For every positive A, its additive inverse will be negative A. Same way, for every negative integer, there exists one positive number. So this is inverse property. This is called inverse property. That only you should write. Inverse property means for every integer or every positive integer a, here every positive integer a, there exists a negative integer. Okay, na? Clear, children? So, example, minus 5. What is the additive inverse of minus 5? What is the additive inverse? Now only I said for every positive integer there is a negative integer. For every negative integer there exists a positive integer. Minus 5 is a negative integer. So its additive inverse will be positive 5. Minus 5 additive inverse is plus 5. Clear? For plus 5 we have to take additive inverse is minus 4. That means here we should just change the symbol of the number. Symbol of an integer. Okay? Right. Next. Find for these children. Minus of, one second. Now find the additive inverse of minus of 4. What is the additive inverse of this number? Now let us see. I told you in previous class for the bracket indicates the multiplication symbol. Now see here, minus into minus become plus for these two. Minus into minus become plus and plus into minus become minus. So this is nothing but minus 4 and its additive inverse is plus 4. So first we have to simplify whether it is a positive number or negative number. When we get the conclusion, then we can write additive inverse easily. Okay, na? Please note it down, children. Or take a screenshot. Yeah. Okay, now? Next. So, three properties we learn: additive identity, multiplicative identity, additive inverse. Okay, now? For every integer, for any integer, the additive identity is always 0 and multiplicative identity is 1. Okay? Next. And you know even numbers, odd numbers. So let us discuss once. So what are even numbers? The numbers which are exactly divisible by 2. Exactly divisible means without leaving any remainder. That means remainder should be 0. Remainder should be 0. So the numbers which are exactly divisible by 2. Exactly divisible by 2 are called even numbers. Example, so 2, 4, 6, 8, 10 and so on. 2 tables simply. So first even number is 2. Next, odd numbers. What are odd numbers? So when a number is divisible by 2, leaves the remainder 1. When a number is divisible by 2, leaves the remainder 1. Such type of numbers are called odd numbers. Leaves the remainder 1. leaves the remainder 1 when it is divisible by 2. Okay na? So first odd number is 1. 1, 3, 5, 7, 9, 11. These are all odd numbers. Okay na? How many even numbers are there? Infinite. How many odd numbers are there? They are also infinite. Okay na? So even numbers or odd numbers. Now we should discuss about the prime numbers. Before going to discuss about prime numbers, we should know about multiple and factor. Multiple, what are called multiples, what are called factors. So both together I am going to explain by taking an example. Okay na? For example, 3 sevens are 21. I am just taking a table. 3 sevens are 21. Here 21 is multiple of 3. 21 is multiple of 3 because 21 is coming in 3 table. As well, 21 is multiple of 7 also. So here 21 is multiple of both 3 and 7. Okay na? And 3 and 7 are factors of 21. 3 and 7 are factors of 21. 21 is multiple of both 3 and 7. Okay na? So simply we can remember the multiple is nothing but a table. 3 table means what are the numbers will come in 3 table? 3, 6, 9, 12, 15, 18. So these are all multiples of 3. Factors means when two numbers are multiply each other, here 3 and 7 both are multiplying, you will get answer, no? That answer is called product. The product is, these two numbers are factors to the product. These two numbers are factors to the product. Write the definition of factor, it will be useful, I think so. So factor is nothing but when two numbers are multiply each other, when two numbers are multiply each other, each of the number is factor to the product. Factor to the product. Okay. So example, 12 5s are 60. 12 5s are 60. Here 12 and 5 are factors of 60. Okay na? Please note it, children. Please note it. Okay na? Now how to find the factors? How to find the factors? Yeah, find factors of 24. Factors of 24. We have to write all the factors. For writing all the factors, we should use the table starting onwards. First, 1 is a factor of any number. 1 is a factor of any number because any number will come in one table. Yeah, here I am taking from one table. 124s are 24. Am I right? I am finding the factors for 24. The 2 table 24 will come. How many times? Yes, 12 times. Very good. 2 12s are 24. 3 table 3 8s are 24. 4 table, yeah, 4 table also will come. 4 6 are 24. 5 table 24 will come? No. 6 table? Yes. 6 4s are 24. Now here observe here children. 4 6 are 6 4s are both are same, no? 4 6 are 6 4s are both are same. That means it is repeating. Now I am deleting this one because both are same. I am erasing this. So therefore the factors are 1 2 3 4 6 8 12 24. Now if you observe that if you take any number, 1 is the common factor and it itself is also a factor. Okay na? I am taking 24, 24 came, 1 also came. 1 is the common factor for every number, any number. Okay children? How many factors are there here? 1, 2, 3, 4, 5, 6, 7, 8 factors. So the number 24 having 8 factors, you know already. But in some cases, asks that find the number of factors of a number. Find the number of factors. Number of factors can be asked or number of divisors. Factor or divisor, both are same. Okay na? So for tell its count, we are having a shortcut. For finding all the factors, we have to do the same process. But finding number of factors, we can find easily. So for example, I am telling that. Let me explain through the example. Suppose I am taking 56. I am taking 56. You know prime factorization of 56. Prime factorization of 56. I am taking 2 table. So 2 28s are, 2 14s are, 2 7s are, 7 1s are. Because 7 won't come in any other table. So this 56 we can write as, this 56 can be written as 2 into 2 into 2 into 7. That means 2 how many times? 2 how many times? Multiplying 3 times. So it is 2 cube. 7 presenting only 1 time. That means 7 power 1. Therefore, number of factors is, you should take only the exponents. What is the exponent of 2? Is 3. Exponent of 7 is 1. Therefore, number of factors are 3 plus 1. That means for this exponent I am adding 1. Same way for this exponent also I should add 1. 1 plus 1. Okay na? 3 plus 1 4. 1 plus 1 2. 4 2s 8. 4 into 2 that is equal to 8. Okay na? So there are number of factors are 8. This method is easy because if the number is given very large number like 2000 or 2500 or 2256, that type of numbers are given means to write all the factors somewhat difficult for us. So that's why for finding number of factors we are using this formula. So because if you take any number, it can be expressed as product of primes. That is fundamental theorem in arithmetic that we'll learn later. I'll discuss to you. Before that, you know about the prime factors, right? Now, see here 24. For 24, how many we have? 8 factors we got. 24, 8 factors. I am doing in the same way. It should be satisfied, no? Now see here 24 I am. 24. What are the prime factors of 24? Yeah, 2 table, 2 12s, 2 6 are, 2 3s are, 3 1s are. So prime factors of 24 is equal to 2 how many times? 1, 2, 3. 3 times. So 3 cube. Still what is remaining? 3 remaining. 3 how many times? 1 time. Therefore number of factors or number of divisors equals to exponents. First exponent is 3 and second exponent is 1. Here same 3 and 1 came. So obviously we will get 8 factors. So this one. Okay now? Please note this. Please note it. I will give this number of factors as a formula wise. You can write that formula also. So first you take a screenshot, then I'll give the formula for that. Yeah, okay children. Now the formula, number of divisors, if a number is expressed as p1 power n1 into p2 power n2 into p3 power n3 and so on like this, where p1, p2, p3 are prime numbers. p1, p2, p3 are prime numbers. Like previously for 56, see how we are taking 2 into 2 into 2. So 2 cube and 7. Here 2 and 7 both are prime numbers. So the prime factorization of every number is any number is unique. So it does not change according to it. Okay na? Every number have its unique factorization, prime factorization. So if a number is expressed as p1 power n1, p2 power n2, p3 power n3 like this. Okay na? Where p1, p2, p3 are prime numbers. Where p1, p2, p3 and so on are primes. Then number of divisors or number of factors. Number of divisors or number of factors equals to n1 plus 1 into n2 plus 1 into n3 plus 1 into and so on. Here how many prime factors are there, prime numbers are there? p1, p2, p3. So each one having the exponent n1, n2, n3. So for the answer we are taking exponent plus 1. First prime number exponent plus 1, second prime number exponent plus 1, third prime number exponent plus 1, all we are multiplied. This is the formula. Simply you can remember that. First find the prime factors. That prime factors are expressed in exponential form. Express the prime factor in exponential form like 2 cube into 7 power 1. Then take the exponents, add 1 to them and multiply. You will get number of divisors. Okay children? Yeah. And you already know about the prime number. What is prime number? Prime numbers. The numbers having exactly 2 factors, one and itself. Exactly 2 factors. Or only 2 factors. The numbers having only 2 factors are called prime numbers. only two factors are called prime numbers. Okay, na? What are the two factors? 1 and itself. Okay, na? 1 and itself. Like 2, 3, 5, 7, 11, 13, 17, 19, like that. Clear, children? Yeah. And we already know that 1 to 100, there are 25 prime numbers. 1 to 100, there are 25 prime numbers. That means 1 to 50, 15 prime numbers, 50 to 100, 10 prime numbers. So total 1 to 100, there are 25 prime numbers. Okay. Same like 100 to 200, there are 21 primes. From 100 to 200, there are 21 primes. And here you already learn about it. 1 is neither prime nor composite. 1 is neither prime nor composite. What are composite numbers? The numbers having more than two factors. Only two factors means prime numbers. More than two factors, composite numbers. Less than two factor, neither prime nor composite. Less than two factor, we have only one number, that is 1. What is that number? 1. Okay, children? So number of factors formula you found. What are prime numbers you know, what are composite numbers also you know. Now, in your coming class, you just say that what are the primes between 1 and 100. Okay. So I said 25 primes now. You write all the 25 primes and find 21 primes 100 to 200 between two. There are 21 primes now. Find those numbers also. Okay, children? Yeah, please note it. 1 minute. Okay, children. So what are the points we discussed today? Number system, natural numbers, whole numbers, integers, non-negative integers, non-positive integers, and three properties: additive identity, multiplicative identity, and additive inverse. Then prime number, composite number, what is factor, what are multiples, next number of factors or number of divisors formula. Okay, na? Yeah, that's it for today, children. We'll meet in next math class. Thank you, one and all.